Hello, hi, namaskar everyone. Just give me a quick response. Am I clearly visible? Am I clearly audible? Can you all see the screen right there in front of you? Is this stream running properly in front of you? I hope you all can see me, you all can hear me. So with this, I welcome you all in this live session on YouTube, our very own channel, PW English Medium channel, where we are going to discuss something really important and significant for all the class 12th students of CBSE from this subject mathematics, that what all you should have covered in your class 11th. What does it mean? It means, let's say you come up with the query that, sir, I have wasted my class 11th. Let's say you come up with the query that, sir, whatever is going to be really important in order to understand class 12 properly, what all is needed so far in mathematics, then this session is for you. I repeat, this session is for anyone and everyone who is entering into class 12, or rather who has already entered into class 12, but now expecting or hoping that, sir, I should be able to understand the whole class 12 more properly, with better clarity, with better understanding. So how are you going to achieve that? How are you going to be able to do that? The only idea is whatever you have studied so far before class 12 should be very well understood by you all. But let's say there are still some gaps. There are still some points which are lagging. So those points we'll try to cover in this session, so that all what is needed as a foundation, as a base to understand class 12 better, will be covered here with this one session. So I hope you understood who can attend this session, who should watch this session, and the third thing, how will this class benefit you? Shall we get started, everyone? Are you all there listening, watching, and understanding this? So with this, if I get started, I'll first of all tell you the feature pylons. Today we'll be doing some questions, some MCQs, some integer type, and there we'll be using this poll feature. So when I ask you a question and if you want to participate in the poll, you can use Google Pylons. Not just that, if you're watching any random video on YouTube, you want PYQs on it, you want short notes on it, you want mind map on it, you want, let's say, some PDFs on it, related to it, relevant to it. All that can be generated by you at absolutely free of cost. Yes, you heard me right. Any random video you're watching on YouTube, not just PW, non-PW videos also, and you want short notes, PYQs, mind maps, or anything relevant or related to that, you can generate it with this Pylons application. That's the beauty or advantage of that. I hope we can get started. So today, what all we'll be discussing or covering in this session, let me brief you or clarify about you that. First of all, I'll very quickly tell you logarithm, because it is used in 12th class in a lot of chapters. So very basics, very quick, simple, straightforward properties, which are very widely used in class 12, in calculus, in a lot of other chapters, even in matrices and determinants. So at a lot of places, you will see it getting used. So those basics will cover. Then I'll tell you some nuances of complex numbers, which you might have forgotten. Some people still struggle with sets. Those basics I'll cover. Then I'll talk about determinants, simple expansion, and Kramer's rule if time permits. Then I'll tell you about quadratics, because people still struggle with quadratics, specifically with its graph, its range and all. We'll talk about that as well. Next thing which we'll be exploring is some few basic stuff or idea related to arithmetic progression and geometric progression, APGP, sequence and series, basics of that. Then yes, people still forget a lot of basics related to trigo as well. So those basics also we'll be covering with this session. Give me a second, everyone. Not just that, I'll tell you some basics of coordinate geometry as well. These are all your basics from class 11th, which you may have forgotten. And then, if time permits, we'll do this PNC or binomial, or maybe from here, I'll try to cover this, but if time doesn't permit, we'll stop there. But I may try to stretch it till statistics. Mensuration, you already know, planes and solid, you have already studied in 10th, so that I'll skip. Probability, I'll skip, because basics of probability you already know. But more of probability, if you want, we'll be discussing in class 12th only. So I hope you got the agenda, what all will be covering. We'll be covering technically all the basics of class 11th, which you must have studied, so that you can comfortably understand class 12th. That's the agenda, that's the motive of today's session. If I begin with the discussion on logarithm. So we are beginning our discussion with logarithm. Everybody, give me a quick thumbs up in the chat box. Shall we get started? Are you all ready? Are you all set? So this session could be of next 2 to 3 hours. We'll try to culminate every possible thing, which will definitely or surely help you in your class 12 journey. Shall we get started, everyone? So if I talk about log, or before I talk about log, let's talk about exponents. So what do you mean by exponent? Let's say there is an exponential function. There is an exponential function y is equals to 3 to the power x. So if I keep giving it different values of x, for example, 3 to the power 1, 3 to the power 2, 3 to the power 3, 3 to the power 4, 3 to the power minus 1, 3 to the power 0, 3 to the power minus 7, and so on. So you will see as soon as I increase x, this 3 to the power 1, 3 to the power 2, 3 to the power 3, this will also keep increasing. But if I decrease x, 3 to the power 0, 3 to the power minus 1, 3 to the power minus 2, 3 to the power minus 3, this will keep decreasing. So always remember, 3 to the power x as a function is an increasing function. It increases if you plot its graph. But if I change it means, let's say if I define a function y is equals to 0.2 to the power x. So what is the beauty here? The beauty is this base, which is 0.2, is less than 1. Now, in this case, if you raise it to higher powers, we know if you increase a number between 0 to 1 to higher powers, it will decrease. I hope you understand this. I repeat, for example, this is 1 by 2. Now, if I ask you higher powers of 1 by 2, let's say this is 1 by 2. What is 1 by 2 square? That is 1 by 4. What is 1 by 2 cube? That is 1 by 8. So, if I ask you what is 1 by 4, that is 1 by 2 square. What is 1 by 8? That is 1 by 2 cube. So, as I am going ahead with the higher powers of 1 by 2, as I am going ahead with the higher powers of 1 by 2, the values are decreasing. So, if the powers are increased, the value decreases. Why? Because clearly it is all happening because of this base which lies between 0 to 1. Did you get my statement? So if the base, there are two cases here. If the base is greater than 1, it will be increasing. For example, 3 to the power x. For example, 5 to the power x, 8 to the power x, and so on. Everybody getting my point? But if the base lies between 0 to 1, if the base lies between 0 to 1, in that case, this will be a decreasing. Did you get my point? So I am giving you some basic idea regarding an exponential function where base is a. So this base will be either between 0 to 1 or greater than 1. But I hope you're understanding this base can never be negative or 1. Did you all get a decent clarity on this? All those students who are watching it sincerely, give me a quick thumbs up or yes that you have gotten it. I repeat, one thing you all must have understood clearly, as long as you're talking about a function a to the power x where the base is greater than 1, it is increasing like this. I hope you're seeing its graph. But if you're talking about the function a to the power x where the base is between 0 to 1, in that case, it decreases. Look at the base 0.2, look at the base 0.4. But one thing is very common here. One thing is assured here. What is that one thing? That all of them will pass through 0, 1. All of them will pass through 0, 1. Why? Can somebody explain that to me? All these functions will pass through 0, 1. Because a to the power 0 is 1. So all of these graphs will intersect at 0, 1. Everybody got a decent idea on exponential function, or shall I re-explain any part here? Tell me honestly. Everybody understood this? Quickly give me a thumbs up. Can I move ahead from here? Shall I discuss a question now? Shall we do a question with this? Let's try and solve this. Now, what do I mean by this? This is 1 by 2. I'll keep it as 1 by 2 raised to the power x square minus 2x. This 1 by 4, can I write as 1 by 2 square? This 1 by 4, can I write as 1 by 2 square? I hope you're okay with that. Now you go back to this question, this graph. Sir, 1 by 2. What is 1 by 2? 1 by 2 as a base is between 0 to 1. 1 by 2 as a base is between 0 to 1. What does it mean? If I ask you to plot the graph of a to the power x, sir, when? I am asking you to draw the graph of 1 by 2 to the power x. I hope you're realizing this 1 by 2 is between 0 to 1. So if the base is between 0 to 1, the graph decreases. The graph goes like this, which means it is a decreasing function. This is a decreasing function. So if it is a decreasing function, what does it mean? It means, let's say there are two values, x1 and x2. So at x1, if I ask you this value, it will be 1 by 2 to the power x1. At x2, if I ask you this value, it will be 1 by 2 to the power x2. Now you tell me, on the graph, x1 was less than x2 because x1 is on the left, x2 is on the right. So we know that x1 is less than x2. But on the graph, 1 by 2 to the power x1 is greater than 1 by 2 to the power x2. Why? Because it is above. On the y-axis, it is above. So will I not say 1 by 2 to the power x1 will be greater than 1 by 2 to the power x2? Sir, why are we discussing it? We are discussing it because I want to give you a general result, a very important and a very crucial general result. And remember it, you will be using it a lot many times in your journey. What is that general result? Let's say I'm told a to the power x is less than a to the power x is less than a to the power y. Now, sir, whenever we see a to the power x less than a to the power y, what do we conclude? It depends on two cases. Which two cases? First case, if the base is between 0 to 1. Second case, if the base is greater than 1. Whenever the base is given to be greater than 1, so you don't have to hesitate. Whatever is the sign between them, the same sign will follow between x and y. So whenever a is greater than 1, the same sign will follow between x and y. But if, let's say, a to the power x is less than a to the power y, where the base is between 0 to 1, then the sign swaps between x and y, which means here the relationship will be x greater than y. Did you understand it? And are you realizing the reason? It is all happening because of this function's nature, its graph. It is decreasing for all the values of a which are less than 1, between 0 and 1. And if the base is greater than 1, it will be increasing. So the relation will be same. Quickly give me a thumbs up in the chat box. Are you all able to digest this? Are you all able to understand this? Now with this, if I proceed with this question, the base 1 by 2, is between 0 to 1. So if the base is between 0 to 1, what happens is the sign swaps. Whatever the sign here is, that sign swaps. So here I'll say this relationship will become x square minus 2x. Instead of less than, it will be greater than 2. Everybody got this? Everybody understood this? Or shall I repeat it? All the participants. Brilliant. Perfect. With this, if I rearrange it, it becomes x square minus 2x minus 2 greater than 0. And I hope you know how to solve this quadratic. This is going to be a simple quadratic in equation. So first of all, minus 2, this is minus 2. Splitting the middle term, I think, is not working well. So what I'll do here is, what I'll suggest you to do is, let us find its roots. So its roots are going to be what? I think we can very easily find its roots. Yes or no? Finding its roots is not going to be a tough task. You all can do it. So first of all, before I try and find its roots, can you help me with its discriminant? Discriminant will be b square minus b square, which is 4, minus 4ac. So 4 into minus 2, that is 8. So it is going to be 12. So discriminant is positive. Discriminant is positive means its roots will be real and distinct. With this, I will solve this. How? Let's talk about that. Let us find its roots. So if I solve it separately, x square minus 2x minus 2 is equal to 0. What will be its roots? Sir, its roots are given by minus b plus minus under root over b square minus 4ac. So b square is 4 minus 4ac minus 4 into 2. That is 8 minus 4 into minus 2 divided by 2a. So this is alpha and beta, the roots of this quadratic. So it is given by what? 2 divides it. It is 2 plus minus 8 plus 4 is 12. 12 is 4 into 3. So it is 2 root 3 divided by 2. So if I simplify this, I'll get 1 plus root 3 and 1 minus root 3. Everybody getting this? Comfortable, everyone? Now, if I talk about this conclusion, can I say for a while, let's say this value over here is your beta and this value over here is your alpha. Everybody got that? Everybody understood that? Now, I hope this is a quadratic. So if this quadratic having coefficient 1 has roots alpha and beta, I can write this quadratic as x minus alpha, x minus beta greater than 0. Yes or no, everyone? Everyone getting this? If the quadratic is splitted as x minus alpha into x minus beta, I think half of my job is done. Why? Because if I know x minus alpha into x minus beta, if you are still confused with x minus alpha and x minus beta, what I could write it as x minus, what was alpha? Alpha was here 1 minus root 3. So I'll write it as 1 minus root 3. And what is beta? Beta is 1 plus root 3. So that is x minus 1 plus root 3. I hope everybody is understanding that, and that should be greater than 0. Yes or no? Now, if I talk about something really crucial, which you must have learnt, I hope in 11th, if you have forgotten it, let me try and highlight it. X minus alpha, x minus beta. If it is supposed to be kept positive, where we know that alpha is the smaller root, beta is the greater root, then I hope you do remember, we divide the number scale like this, and we define these critical points as alpha and beta, and we know that this section is positive, this is negative, this is positive. We want this expression to be positive, so this expression is found to be positive when x is less than alpha or x is greater than beta, where, mind you students, alpha is the smaller root, beta is the greater root. Do you all remember that result? Yes or no, everyone? Same idea. Again, that's a very crucial general result, which I'll ask you all to remember if you all can. So if I get back to this question with this general result, this is your alpha smaller root, this is beta greater root. So what is going to be the final answer? Sir, x minus alpha into x minus beta positive happens before alpha and after beta. Able to understand my language? Able to digest what I'm saying? So with this, my final answer will be that x should be less than a smaller root, which is 1 minus root 3, or x should be greater than bigger root, which is 1 plus root 3. Or if you wish to write it, you could have written it like this: x belongs to, this sign says belongs to, remember that everyone, less than minus 1 by root 3, that is minus infinity to 1 minus root 3, but 1 minus root 3 excluded, open interval, or means union, 1 plus root 3 to infinity, 1 plus root 3 to infinity. Everybody understood that, or shall I re-explain any part of this question? Did you all get this? Did you get the whole explanation of this entire question? Everybody. First of all, I proceeded with this idea, graphical approach, where I told you this was decreasing, so sign swapped. And when the sign swapped, this is how you deal with this simple question, by simply solving an inequality. So these general results, everything you'll remember. Now, once you have understood exponential function, now gradually let's move towards logarithmic function. How do we define logarithmic function? Logarithm, first of all, is an extension of exponential only. For example, if I say 2 to the power, let's say 2 to the power 3 is 8. So this is an exponent form where the base is 2, power is 3, and the value is 8. But if this exponent were to be written in the form of logarithm, so I'll write it as log of 8 at base 2 is 3. I hope you understand logarithm. From exponents, how do we reach to it? I hope you understand that. It means that this base 2 should be raised to the power 3 will result into 8. For example, if I were to ask you, what will be log of 1 10,000, let's say, at base 10, what will be the value of it? So what is the meaning of logarithm now? I hope you are getting it. Logarithm now means that this 10 should be raised to what power so that it can result into 10,000. So indirectly, what am I asking you? I am asking you 10 to the power x is equal to 10,000. Yes or no? And what is 10,000? So 10,000 is 10 to the power 4. And this is what? 10 to the power x. Both base are same. Non-negative. So powers can be compared and I can say that x is nothing but what? 4. So are you understanding the concept of logarithm? It is nothing but an extension of exponents, which means this 10 if raised to the power 4 gives you 10,000. So did you all get a basic idea, a decent idea about logarithm? And if you understood logarithm, that how are we attaining logarithm from exponents? I hope I need not explain it. Let's take one more example. We know 5 cube is 125. So in terms of logarithm, how will I write it? I'll write it as log of 125 at base 5. So the question becomes now what? The question says that what power 5 should be raised to so that it gives you 125. So the answer is 3. So if I want to talk about the power, the index, there we use logarithm. First of all, are you understanding the need of logarithm? So if you have understood that, I think you can crack the question very easily. Just hold on for a while, students. Give me a moment, everyone. I hope I'm clearly visible and audible. The stream is running smoothly. You all can hear me. You all can see me. It is perfectly fine, visible and audible to all the participants. Shall I continue with this? Okay, so there we are. Give me a moment, everyone. I think there are the comments. I'm just shifting it there so that it can be. Okay, there we are. Great. I hope everybody is with me. So far, no confusion. So logarithm is an inverse function of exponent, which means the way exponent was behaving, in the same fashion logarithm will behave. Which means here, if I again wish to define logarithm, pay attention everyone, log of, let's say, x I'm taking at base a, which is given as y. So if I want to take or write in its exponents form, what will it tell me? It will say a to the power y is equal to x, yes or no? It will say a to the power y is equal to x. So there are two cases. Do you remember that? First case, when the base is between 0 to 1. Second case, when the base is greater than 1. So first case, when the base is between 0 to 1. Second case, when the base is greater than 1. Everybody understanding it comfortably? Logarithm basics I'm talking about. With this, I hope you're now realizing when the base is between 0 to 1, its graph is really simple. Again, a decreasing function like this. But when you talk about log x, when the base is greater than 1, it is an increasing function and its graph goes like this. Which means what? Which means, let's say, if you are looking at the x-axis, it will take all the values greater than 0. But if you look at the y-axis, it will take all the values from minus infinity to infinity. That's the graph of y is equals to log x at base a, specifically when a is greater than 1. Again here, when you look at the graph of log x, when you look at it as from the x-axis perspective, this is graph of log x at base a. When the base is between 0 to 1, it takes all the values greater than 0, x, the domain. And if I ask you that what values does it generate, so range, it will give me from minus infinity to infinity. Everyone comfortably got this idea. Everyone understood that. Now with this, I hope this is how the different versions of your graphs of logarithm looks like. Again, the simplest idea is really simple, that in this case, look at the base 2, e, 4, they all are greater than 1. Look at the base 0.2, 0.5 and all, they are less than 1. So when they are less than 1, the graph is decreasing. I hope you're noticing that. When they are greater than 1, the graph is increasing like this. I hope you noticed it. The same we did with the exponential function as well. If you got a decent clarity about whatever I've done so far, can you help me with this question? So I'm doing a poll here. Let's see how many of you get the right answer. So I'm conducting a poll. Let's see how many of you get the right answer. I'm really sorry. This is an input type, not an option type. So integer type, there will be an integer answer to this question. Let's see how many of you get it right. Participate in this poll and let's understand how many of you get it right, shall we? If I am asked log of 10 1 degree, log of 10 2 degree, till log of 10 89 degree. So if you are observant enough, you would be in a position to crack that somewhere in the between, sir, there will be log of 10 45 degree. What does it mean? There are all these values, log of 10 1 degree, getting multiplied with log of 10 2 degree and so on until it is going till last term, which is log of 10 89 degree. Everybody got this? And they all are getting multiplied. They all are getting multiplied. Which means what? I hope everybody is noticing something really beautiful and interesting. 1045. Do we know 1045? It is 1. So if this is 1, this value becomes what? This value becomes log 1. Now remember this, log 1 at any base is 0. Why? Let's say this is m for a while. So I'm asking you a to the power m to be 1. So if a to the power m is 1, can you help me? A being non-zero, raised to a certain power is giving you 1. When does that happen? It happens, sir, when m is 0. So always remember log 1 at any base is 0. So this log 1045 becomes 0. And 0 into anything is going to be 0. So what is going to be the answer here? 0. How many of you got it? How many of you cracked it? Everybody realized, understood, and saw how are we getting the answer as 0? Yes or no? All the participants. Shall I move ahead from here? With this, let's try one more question. Let us try to solve another question. How do we do it? Pay attention, everyone. This is what I need to figure out. Let's call it y for a while. So y I'm taking as 3 to the power 2 log 3 at base 9. I hope I can write it like this. Yes or no, everyone? Now, sir, there is one more property. Which property? Of logarithm. Let's say if I'm given log of m at base a to the power n. So this base a is raised to a certain power. Although before I discuss this, I hope you all know this property. Log of m to the power n is always written as n log m at the same base, let's say. So there is one more property. Let's say I'm taking log of m at base a to the power n. So if the power was here, it came to the front. If the power is raised as a power of base, then again it will come to the front, but its reciprocal comes to the front, which means a to the power n, give me 1 by n to the front, and it will be log of m at base a. How many of you are aware of this property? How many of you are aware of this property? Now, if you are, we'll be using this property here in this question. Shall we? Can we? Why and how? Let's talk about that. So I'll be saying y is going to be 3 to the power. This 2, I'll write it here like that. Log of 3 base 9. This 9 can I write as 3 square if you're okay with that? This 9 can I write as 3 square if you're okay with that? Yes or no? And if it is written as 3 square, this square, I hope remember, comes to the front as the reciprocal. So this is written as 3 to the power 2 log 3 at base 3. And this 2 comes to the front as 1 by 2. Yes or no? Now again, I'm sure you must have remembered one more property, that log of something at the same base is always 1. Because I hope you remember a to the power 1 is a. Yes or no? So if I could use that result, I think I've gotten something really beautiful here. 2 by 2 is 1. So that gets cancelled. Log 3 base 3 is 1. So it is 3 to the power 1 and the answer is 3. How many of you cracked it? How many of you understood it? How many of you were able to think like this? If you have any other approaches or ideas, do tell me. I'll be really happy in seeing those approaches. So far, everyone is comfortable with whatever is told regarding logarithm. If you are comfortable, let's talk about few more things. Which things? Few more properties related to logarithm. First of all, these properties are true if m and n are positive and a is positive and it is not 1. The basic requirement for logarithm to be defined. I hope you remember, if a value is passed as an argument to log, we have seen its graph, it has to be positive and the base is always positive and it is never 1. So I'm following these 3 conditions while explaining you these formulae. So the first formula is log of mn is log of m plus log of n at the same base. Which means someday if I'm given this, I'll write it like this. But usually the mistake students commit is this, that let's say if they are given something like this, log of m plus n, I don't know why, but they write it like this, log m into log n, which is wrong, which is incorrect. Are you getting it? The correct version is log of m plus log of n is log of mn. This version is wrong. Similarly, one mistake they again commit is, let's say, of course, the correct version is log of m upon n is log m minus log n, where the base is same. But let's say what students do is, I have seen them often doing it as log of m upon log n. When they see, sometimes they write it as log m minus n, which is again false, wrong. Will you all remember that result? I hope these 2 results are very well understood by you all. Shall I move ahead from here, all the participants? With this, let's talk about another result as we have just discussed. Log m to the power b is b log m. Yes or no? Next result. Log m at base a to the power b is 1 by b log m at the same base a. Do you remember these results? Yes or no? Yes or no? A is greater than 0. Yes, it is not degree, it is simply 0. There's nothing here. With this, if I now move ahead, shall we try one more question? Let's see how many of you are able to do it. So once you get the answer, do tell me your response in the comment box. Before I solve this question, I'd like to tell you something really interesting. Let's say if you are given log b base a and you want this to be on a different base. Let's say you want the base to be c. how do you convert it into a different base? The idea is really simple. You write log b in the numerator. You write log a in the denominator. Now, whichever base you want, you can keep the base as, let's say you want the base to be 10, you want the base to be e, you want the base to be c, whatever base you want, you can put that base here. Did you understand that approach? Now, if you have gotten that approach, I'll tell you a corollary of it. What is the corollary here? Pay attention, everyone. That's even more interesting. The corollary is that if it is log b base a, sir, I want it to be in base a. Can we convert it into the base a? Yes, I can write it as log b. I hope you understand. Divided by log a. Sorry, I want it to be in base b. It is already in base a. What if I want it to be in base b? How can I make it look like in base b? So what I'll do is, whatever base you want, you can have that base. So I want the base to be b. So I'll write the base b here like this. But we do know that log b at base b will be 1. So I'll be writing it as 1 by log a base b. Did you learn something interesting? What is that interesting thing? That interesting thing is really simple, that log b base a can always be written as 1 upon log a base b, which means these a and b can be swapped if I take their reciprocal like this. Will you all remember that? What does it mean? It means that here in the question which we are solving, I think this question can very easily be done if you know that property. How? Pay attention. This is 1 by n log n base 2. So if I take in the numerator, will it not look like log 2 at base n? Will this not look like log 3 at base n, plus so on until log 53 at base n? Is it not what I've gotten? Yes or no? All the participants. With this, we know log m plus log n is log mn. So if they are getting added, I'll be writing it as log of, I hope you're noticing the base is same. The base is same. So I can write it as log of 2 into 3 into 4 into 5 until what? 53 whole at base n. Yes or no? Everyone. Can you help me? What is the product of first n natural numbers? Definitely, Sachin, we would someday. 1 into 2 into 3 into 4 until 53 is nothing but what? 53 factorial. And if it is 53 factorial, I think I do have the answer now, because it is log of 53 factorial at base n. If I swap, again, 53 factorial and n, I want it to be swapped. So I hope you know, you can simply take their reciprocal and you can write it as 1 by log of n at base 53 factorial, which you were supposed to prove. Easy, straightforward. Same here, Sachin. I'm also eagerly waiting to meet you all in the PARISHRAM batch, English medium. Yes, of course. We will be meeting and interacting and discussing some really decent, good questions along with their solutions. So let's make mathematics interesting. Shall I move ahead? So logarithm basics, which you'll be using in 12th class, are done. Now let's move towards complex numbers. Some basics you should be aware of. What is it? So Euler, however you want to pronounce him, was the mathematician who came up with this thought that, sir, what if I want to solve a quadratic equation, this x square plus 1 is equals to 0. So when he did it, he said that x square is equal to minus 1. But we know in the world of real numbers, a real number when squared is always non-negative. It is either 0 or greater than 0. But sir, you're wanting that a number when squared, a real number when squared, should give me minus 1, a negative number. Is that really possible? Of course, with real numbers, it was never possible. But how do we solve this equation in that case? So Euler suggested, as a mathematician, he said that let's assume this minus 1 as iota, a Greek symbol, under root over minus 1 as iota. So what we do is, of course, to solve it, x I'll say to be plus minus under root over minus 1. But from the perspective of the real world, the real number world, I know that under root over negative numbers is not defined. But he said, let us keep it defined. Let us assume it to be iota for a while. So he said that if it is assumed to be iota, this equation indeed has a solution which is given by plus minus iota. So if this quadratic was needed to be solved, he said it has solution iota and minus iota. So first of all, of course, under root over minus 1 does not exist in the real world. So it was a hypothesis, it was an imagination, and it is going to be an imaginary number. Now, with this imagination, of course, if I talk about under root over minus 1, as we have discussed minus iota, what is under root over minus 4? So it will be under root over 4 into under root over minus 1. Under root over 4 is 2, under root over minus 1 is iota. So now we could define these numbers, although they all are imaginary, but still we could. Under root over minus 7 is under root 7 iota. Under root over 18 is, I hope you are realizing, 3 root 2. 18 is 3 root 2, 9 into 2. So 9 comes out as 3 root 2. And this minus 1 over an under root inside an under root is iota. Everybody understanding the world of imaginary numbers? Yes or no? With this, if I now continue further, remember this as a result, that here there is something really crucial. You need to remember that if we have taken Greek letter iota as under root over minus 1, if I square it on both these sides, if I'm squaring it on both these sides, I hope you're realizing iota square will be minus 1. Yes or no? And if I ask you iota cube will be iota square into iota. Iota square is minus 1, so it is minus 1 into iota. So iota cube will be minus 1. What will be iota to the power 4? Iota to the power 4 will be iota square into iota square. Iota square is minus 1, so minus 1 into minus 1 is plus 1. So three things I'm asking you to remember. Iota is iota. Iota to the power 2 is minus 1. Iota cube is minus iota. And iota to the power 4 is 1. Now it follows this cyclicity of 4. If you wish to find iota to the power 5, it will be iota. I repeat, if you want to find iota to the power 5, it will be iota. Iota to the power 6 will be minus 1. Iota to the power 7 will be minus iota. And iota to the power 8 will again be 1. Which means again, if I ask you iota to the power 9, it will be 5 and so on. Did you all understand the pattern? Did you all see the pattern? Now, this is something basic, easy, self-explanatory and understandable. Something really crucial. If you all can, then please remember it. If you raise iota to a power, and if you are raising it to 4 consecutive numbers, and if you are adding it, the sum will always be 0. Why? I hope it is logically understandable that one power will give me 1, 1 will give me minus 1, another power will give me iota, another power will give me minus iota. I repeat, if I am solving this, iota to the power 10. What is iota to the power 10? Sir, iota to the power 10 is iota to the power, I hope you're understanding, 10 is what? 4 into 2, 8 plus 2. So it is equivalent to iota square. If you didn't get it, I'll explain it with more ease. Iota to the power 10, I am saying is, if you divide it by 4, 10 if you divide by 4, you get the remainder as 2. So it will be equivalent to 2. I mean iota square. If you divide 11 by 4, the remainder is 3. So iota to the power 11 is equivalent to iota cube. If you divide 13 by 4, you get the remainder as 1. So it is equivalent to iota to the power 1. Last one, iota to the power 14. If you divide this 14 by 4, 10, 11, I think there is a mistake. This should have been 12 and this should have been 13. So iota to the power 12 when you divide by 4, the remainder is 0. Can I write it as 4? It is fine. Yes or no? Next thing is iota to the power 13 when divided by 4, remainder 1. So it is treated as iota to the power 1 as well. Now I hope you are clearly realizing iota square is minus 1, iota cube is minus iota to the power 4 is plus 1, and iota to the power 1 is iota. So iota, minus 1 and 1 are cancelled and it leaves you with the 0. So this will always be true. As a property, sum of 4 consecutive powers of iota is always 0. Did you all get this? Will you all remember that? Now one mistake a lot of students commit is that they treat it like this, which is wrong. Remember this is wrong. So what are you saying? We are not understanding. Let me explain that. Let's say if I ask you minus 2 into minus 3, under root over minus 2 into under root over minus 3. So people do it like this, minus 2 into minus 3 inside an under root, and they say minus 2 into minus 3 is 6, so answer is 6, which is false. This property is valid, that this is splitted and you want to club it, can be done only when either both of them are positive or one of them is positive, other one is negative. But if both of them are negative, you cannot do it like this. which means if I am given root 2 into root 3, I can write it as root 6. If I am given root 2 into minus root 3, I can write it as minus root 6, which is of course root 6 iota. If I am given minus root 2 into root 3, then also I can do this minus root over minus 6, which is again root 6 iota. But if I am given under root over minus 2 into under root over minus 3, then the way we were doing it was wrong. Under root over minus 2 is root 2 iota. Under root over minus 3 is root 3 iota. And now root 2 into root 3 is root 6. And iota into iota is iota square, which is minus 1. So can you believe this? Yes. Under root over minus 2 into under root over minus 3 is not plus 6. It is minus of under root 6. Did you all get this? Did you all understand this? I am sure some of you were not aware of it. And if you were not, I hope now you clearly understood this. Shall I move ahead from here, all the participants? Can I go further with this? This is all you already know. This I'll be skipping. You can revise it. I hope you know that after the session, this entire PDF of the basics of 11th will be uploaded on our WhatsApp channel. You can follow our WhatsApp channel. The link is given in the description. There, this entire PDF, all the notes of basics of 11th will get uploaded. Now, getting back to the discussion of set. Now, what is set? I hope you understand. Let's say there is a set of all the vowels in the English alphabet, which is given by A, E, I, O, U. So these 5 letters are written in a curly bracket where this set is given a name capital V. So set means collection of objects, which is written like this, or there are some other methods as well, which I'll explore, I'll discuss, but I hope this method is very well understood by everyone. Yes or no? Can I move ahead from here, all the participants? Everybody understood that? Going ahead from here, what do we see next? Sets, I hope you have understood pretty well, clearly. So this is all theory, which I have just kept for your revision. When you receive this PDF, you can do the revision. For example, let's say roster form of set representation is really simple. Let's say if I talk about all the odd natural numbers less than 10. So this can be a set, a collection of numbers. Which kind of numbers? The numbers which are less than 10. All the odd natural numbers. So all the odd natural numbers less than 10 are 1, 2, 3. Sorry, 1, 3, 5, 7, 9. So this is that collection. So this is how we define the set A as curly brackets 1, 3, 5, 7, 9. Odd natural numbers less than 10. Shall I move ahead from here, all the participants, if you have gotten clarity on this? But there's one more form, which is called set builder form. We'll talk about that, don't worry. In set builder form, what we do is, this is how we write it. There is a set A of all prime numbers less than 10. So in set builder form, how do we write it? We write it like this. There is a set A which contains X such that, this line is read as such that X is a prime number less than 10. What does it mean? I could have written it like the set A in the roster form is prime numbers 2, 3, 5, 7, yes or no? So all the prime numbers less than 10 can be written like this. This is the way of writing it. This is called the roster form. But if I want to write it in its set builder form, that is given by A is a set which contains X such that, this line here means such that X is a prime number less than 10. This is called the set builder form. Did you all understand this? All the participants? Shall I move ahead from here? Now there is one more thing which is called the subset, concept of subset. Let's say there is a set A or set V, which is the set of all the vowels like A, E, I, O, U. There is a set, let's say, let's say A, which is the set of all the letters in the English alphabet, which is like A, B, C, D, and so on until X, Y, Z. Now, do you all not think that this set V is a subset of the set A? Because whatever is there in this set V is taken from this set A. So some things or some elements are taken out and kept in another set V. This set here is said to be the subset of A, and mathematically it is denoted by V subset of A. Did you all get it? Did you all understand this? Shall I move ahead from here, all the participants? Are you comfortably getting it? Yes, yes, Shiv Shankar Kumar. Good to have you. I hope so far there is no confusion regarding this. One more thing I want to discuss with you is, let's say there is a set X and it contains 3 elements, 1, 2, 3. Now, how do you define its subsets? There can be multiple subsets. Let's say first subset is 1, second subset is 2, third subset is 3. The other subset could be 1, 2. The other subset could be 2, 3. The other subset could be 1, 3. One more subset could be 1, 2, 3. And there can be one more subset which is nothing. Subset means what? You take something out of it. So if you are taking nothing out of it, that is also a set. So how many subsets does it have? So if I ask you 1, 2, 3, 4, 5, 6, 7, 8. So if it has 3 elements, there are 8 subsets of it. Sir, is there any way of counting or calculating this number without even writing all these subsets? Yes. That is given by if number of subsets of X I am asked, I'll simply write it as 2 as a fixed number raised to the power number of elements X has. So X has how many elements? 3. So it will be 2 to the power 3, 8. So there will be 8 subsets of this set X. With permutation and combination, you can prove it very easily. With each element, there are 2 choices. Either one is going to be a part of subset or it is not going to be the part of subset. So 2 into 2 into 2, that's 2 cube, 8. Everybody understood that? Everybody got this? I think that's exactly what we are explained here. You got it, understood it clearly. So there is another terminology which is called power set of A. Power set of A means if I write all the subsets of a set A in a set, then it is called the power set. Sir, what does it mean? Have patience, I'll explain. Let's say there is a set A which is 1, 2, 3, which contains elements 1, 2, 3. So what are going to be its subset? Sir, 5, 1, 2, 3, 1, 2, 1, 3, 2, 3, 1, 2, 3. These all are going to be its subsets. So if I create a set which contains all the subsets of a set, then it is called the power set. Did you get it? Everybody? I hope there is no confusion regarding that. With this, there is something really crucial which is discussed a lot many times regarding sets, regarding operations on sets, union and intersection. Let's say I ask you, how many of you in our class like having tea? How many of you in our class like having coffee? So there certainly are going to be some people who like only tea. So these are those people who like only tea, yes or no? There are certain people in our class who like coffee only, which means they don't like tea. And there are certain people who like both. Let me just remove it. I'll write it separately somewhere. So there are certain people in our class who like tea and coffee both. There are certain people in our class who like tea and coffee both. So are you understanding this? Then sir, if this green box represented our class, what is this region representing outside these circles? I hope somebody must have noticed or highlighted. This means neither tea nor coffee. Yes or no? If this is the set belongs to all the people who like tea, this set contains all the elements who like coffee, then this common region is reserved by those people who like both tea and coffee. And this outer region, still inside our class, represents the people who like neither tea nor coffee. Everybody understood that? Brilliant. Definitely, Shivansh. It will be used in 11th and 12th as well, very widely. So if I talk about few operations related to sets, let's say there is this set A, and there is another set, set B, right? So these are our two sets, set A and set B. Set A has elements 1, 2, 3. Set B has elements 4, 5. And set C, sorry, intersection of A and B has 7 and 8. Now, if I ask you, what is there in A union B? What is there in A intersection B? Can you tell me that? My first question, A union B. So what is A union B? Union means or. It means either A or B or both. Or both. Mathematically, it means that. So either A means this, either B means this, either A only or B only, and this means A and B both. So I hope you're realizing union means what? Take everything. So A union B means 1, 2, 3, 4, 5, 7, 8. So A union B, if I want to write, it will be 1, 2, 3, 4, 5, and 7, 8. Everybody understood the concept of union? Yes or no? All the participants. What if I ask you, what will be A intersection B? Now, intersection in the world of mathematics is read as AND. So, AND means A as well as B. So, what does it mean? It means A and B both must exist. So, A and B both exist in this region. This region belonged by both A and B. Perfect, Shivanshikar. So with this, I'll be saying that here, if we want to talk about A intersection B, it means the elements which are there in both 7 and 8. So everybody understood the concept of union and intersection comfortably? Yes or no, all the participants? Can I move ahead from here? Everybody. Yes or no? Understanding whatever is being explained? Can I move ahead from here? With this, if I now talk about intersection, this we have already understood. Let's try and solve a question and we'll get more clarity about union and intersection. This question says that there are 1,000 people in a group. So in that group, there are 1,000 people. Okay. And in that group, there are how many people? Total 1,000. So there are 1,000 people in that group. Let me start a poll as well. Let's see how many of you get it right. So a timeless poll has started. Let's see how many of you are able to do it. So in that 1,000 people, there are 750 people who can speak Hindi. So there are 750 people who can speak Hindi. And there are 400 who can speak English. So there are 400 who can speak English. I hope there is no confusion so far on whatever is done. Brilliant. Perfect. Now with this, what are we told next? Sir, we are told that number of people who speak Hindi only could be what? Let's try and figure it out. So first of all, there are no people who speak neither Hindi nor English. So this categorization or classification is done on Hindi and English. So there, if I wish to write, there is a formula. I repeat, the formula says that number of people who speak Hindi plus number of people who speak English minus number of people who speak Hindi and English will always be equal to number of people who speak Hindi or English. I repeat, this formula says number of people who speak Hindi is 750 plus number of people who speak English is 400 minus number of people who speak Hindi as well as English will be equal to number of people who speak either Hindi only or English only or both, which means this is going to be 1,000. Everybody understood that? How did I write it? All the participants. With this, I think the job is done. 700 plus 400 is 1100. So this is 1150. 1150 minus 1000 is 150. This goes to the other side. So number of people who speak Hindi as well as English will be 150. Correct me if I'm wrong. So your answer, am I making any mistake? Let me just calculate it. None of these is there, but still, this is 1150. 1150 minus 1000 is 150. So your answer will be 150. None of these. Option D should be the correct answer. Let's see how many of you get it right. So I think some of you, nobody. Okay, no worries. With this, if I move ahead, what do I see? Next is going to be our next concept. I hope so far there is no confusion on whatever is done. Now, let's talk about determinants. This is also, you must have studied in it 11th class, yes or no? What is determinant? First of all, if I ask you about the data, the arrangement, let's say if I arrange some data in row and column, And this data is arranged in a 3 by 3 row and column structure. Or let's say if I arrange the data in a 2 by 2 structure, which means 2 rows and 2 columns, this represents number of rows and this represents number of columns. This is determinant as a chapter we'll be studying in 11th, 12th specifically, but you may need it in 11th as well, and you may need it even before studying the chapter determinants. So I am explaining it here. How do we use it? Pay attention, everyone. Determinant means basically it's an extension of matrices. On matrices, we perform in an operation and that is called determinant. So if I arrange some data in a 2 by 2 manner, which means 2 rows and 2 columns like this, 2, 3, 1 and 7. And let's say this is a matrix A. Matrix means arrangement of data in rows and columns. So if it is a square matrix, means number of rows and columns are same. There you can take its determinant. So determinant of A is denoted by this, which is given by 2, 3, 1 and 7. And here, if you want to find its value, it's really simple. 2 into 7 minus 1 into 3. 2 into 7 is clearly 14 and 1 into 3 is 3 and 14 minus 3 is 11. That's your value. Sir, if you're talking about a 2 by 2 determinant, will there exist a 3 by 3 as well? Yes. And that idea I'll give you when we study this chapter, determinants, in 12th standard. Don't worry, we'll study it dedicatedly. We'll talk about all the properties and everything related to that. So don't worry about that. All of that we'll study and explore it with utmost clarity. So don't worry about anything related to determinants. We'll study it as a chapter, a dedicated chapter. Now, let us talk about quadratic equation. First of all, pay attention, everyone. I think these are the basics which you all are already aware of. The first one being this, where you say algebraic expression where ax square plus bx plus c, and of course a is not 0, b and c are real, is called a real quadratic expression. Yes or no? With this, I hope you know b square minus 4ac is called the discriminant. This is what you have studied till 10th. The discriminant usually or conventionally or traditionally denoted by d or delta. Getting it, everyone? Now, of course, Sridhar Acharya was an Indian mathematician who came up with this idea. He gave this quadratic formula where if you want to solve a quadratic, you can solve it by minus b plus minus under root over b square minus 4ac by 2a. And he came up with some more conclusions. I'll talk about this. But before I talk about this, I want to talk about this, that if this is a quadratic ax square plus bx plus c is equal to 0, yes, I was there. So if it has two roots alpha and beta, sum of the roots will be given by minus b by a and product of the roots will be given by c by a. I'll get back to the discussion. When we talk about a quadratic and we talk about this quadratic ax square plus bx plus c is equal to 0, which has its discriminant given by b square minus 4ac. So I hope you remember Sridhar Acharya formula says that alpha and beta, the two roots of it are given by minus b and plus minus under root over b square minus 4ac upon 2a. So that's under root d. So a lot matters on this d regarding alpha and beta. If you want alpha and beta to be defined, a lot matters on this d. So if this d is positive, roots will be real because it all will be real. So if d is positive, we say the roots are real and distinct. If d is 0, this whole becomes 0. So roots will be minus b by 2a. So if d is 0, the roots are real and equal. But if d is negative, complex numbers, imaginary. So are you realizing? If d is negative, under root over negative, iota comes into picture. So now the roots will be imaginary, or in a better language, complex. So there, if d is negative, the roots are imaginary, but still distinct, different. Yes or no? Everybody understood that? So I think that part is very well understood by you all. There is something very interesting I wanted to discuss with you all. Remember this. Let's say there is a quadratic ax square plus bx plus c is equal to 0, where a is of course not 0 and a, b, c all are real numbers. A, B, C all are real numbers. Let's call it rational for a while. They all are rational. I hope you understand what are rational numbers. P by Q form where Q is not 0. So if it has one of the roots as alpha, other root as beta. Let's say alpha I have gotten is P plus root Q. then trust me, other root is going to be p minus root q. The condition is a, b, c should be rational. This property will not hold true if any of a, b, c is irrational. In that case, you cannot claim it like this. Let's say some days you see a quadratic which has one of the roots as 2 plus root 3. You can say that other root will be 2 minus root 3. Given a, b, c, the coefficients and the constant term are rational. Getting my point, everyone? So that's a very crucial property. And conjugate wise, they are pairwise conjugate, 2 plus root 3, 2 minus root 3. The same kind of pair exists with complex roots and imaginary roots as well. If one of the roots is, let's say, 2 plus 3 iota, then other root will be 2 minus 3 iota. Well, this property will be true only for a real quadratic equation, which means ax square plus bx plus c is equal to 0, where a, b, c should be real. If it is a complex quadratic equation, then again, it will be false. Are you all able to digest all what is being said? I hope I'm not confusing anyone. Yes or no? So far, you have gotten a decent clarity on this. You already know it, this particular part, where I'm saying, if there is a quadratic expression ax square plus bx plus c, which has two roots alpha and beta, so I'll write this quadratic expression as f of x as a times f of x as a times x minus alpha into x minus beta. I hope you got it. Everybody with me on this so far? There is no confusion on this regarding? Now, graph of a quadratic expression. This is what you will need in 12th standard as well, specifically when we talk about calculus part, application of derivatives and all. So let's understand it so that when we discuss it in class 12th standard, calculus part specifically, you don't feel confused, right? So let's talk about that. Hold on for a while. Let's say we are discussing about a quadratic ax square plus bx plus c is equal to 0, where one thing is assured, whenever I'm saying it is a quadratic, a is never 0, and everything b and c all are real. They all are real, right? With this, there are two things. I am just asking you to notice two things: the value of a and its discriminant. Pay attention, everyone. If value of a, hold on for a while, students. 1, 2, 3, 4, 5, 6. Okay. I repeat, I'll begin with this first case. Pay attention, everyone. If value of a, I'm really sorry. Hope it is correct. Yes. If value of a is positive and discriminant is positive, which means a is positive, quadratic, when drawn as a graph, when you try to draw the graph of a quadratic, which means here, this is y is equals to x square plus bx plus c. So if you wish to draw its graph, pay attention, everyone. A lot depends on the coefficient of x square and its discriminant. Coefficient of x square is positive, a is positive, it will be an upward facing parabola. And if you are talking about discriminant greater than 0, that means it will have two real and distinct roots. Roots or solution means what? It is intersecting x-axis at two distinct points, which are going to be the roots here. Now, y-axis could be anywhere, here, here, or here. Yes or no? So I hope that part is very well understood by everyone. Can I move ahead from here? Everybody. Second conclusion. What if a is still positive, but discriminant is 0? So when discriminant is 0, the roots are still real, but equal. So if roots mean solutions are there, I'll say x-axis is touched at exactly one point, but a was positive. That means parabola will be upward facing. Getting my point, everyone? Yes or no? Next conclusion. Let's say a is still positive, but this time discriminant is negative. So if discriminant is set to be negative, pay attention, everyone, it will not have any real roots. It will have complex roots, imaginary roots, which means it will not be intersecting the x-axis. Because if it intersects the x-axis, it will have those points as solutions, but it has discriminant to be negative. So it will not have any real solutions, which means what? Graph will still be upward facing because of a being positive, but x-axis will lie below it because it will not intersect the x-axis because it does not have any real roots. Got my point, everyone? Shall I move ahead from here? Next case. A is negative, D is positive. A negative would mean downward facing parabola, and D positive means the parabola will get intersected at two distinct points by x-axis because real and distinct roots. I hope it is more comfortable and convenient now. Next case, if A is, I'm really sorry, did I case A to be negative? Yes. If A here is still negative, but D is 0. So A negative would mean downward facing parabola, but D being 0 would mean that x-axis will be touched at exactly one point, and that point will be the solutions or roots of this quadratic, where roots are equal and real. Yes or no? Last case, where A is negative, what does it mean? Downward facing parabola, but this time D is also negative. D means discriminant. So if discriminant is also negative, what does it mean? Sir, in that case, if discriminant is negative, it means your x-axis is not intersected at any point. Because here I hope you're realizing it does not have any real solutions. Discriminant is negative. So this is x-axis which lies absolutely above the parabola. I hope no confusion so far. If I could simply summarize something really crucial, whatever I've said so far is something really important. Pay attention, everyone. As long as A is positive, it will be an upward facing parabola. It will always be an upward facing parabola like this. And as long as A is negative, it will be a downward facing parabola. One thing you should always remember in life is that if it is an upward facing parabola, it will have its minima at minus b by 2a, and its minimum value will be minus d by 4a. This will be the vertex of the parabola. If it is downward facing parabola, which means A is negative, in that case, this will be the vertex of the parabola, same minus b by 2a, comma minus d by 4a. Sir, we cannot remember these kind of tricky or lengthy or complicated formulae, then have patience. Once I teach you application of derivatives or quadratic someday, I'll explain it with more details, but right now I'm just giving you the result. Everybody comfortably got this? Now, with this, I'm moving towards sequence and series. Let me have a 5 minutes break and then we'll resume. It is 9:05 right now. We'll resume at 9:15. Is that okay? Sorry, it is 9:10 right now. We'll resume at 9:15. So there is a break, a small break, and then we'll resume in a while. So just give me 5 minutes, okay? All right, everyone, just give me a quick confirmation. We are back. So let's resume. I hope I'm clearly visible and audible. Let us resume our discussion with AP, and something basic related to the sequence and series, which will be quite useful for you all in your 12th standard journey. Shall we? So here we are. It says there is a sequence. If the sequence is written somewhat like this, I hope you know it. If the sequence is written somewhat like this, 2, 2 plus 3, 5, 5 plus 3, 8, 8 plus 3, 11, 11 plus 3 is 14, and so on. So what I'm seeing is that each term has a fixed difference, which means a term minus its previous term is giving me a fixed number, which means what? Which means this is said to be an arithmetic progression. Now, if I wish to generalize few things, I hope you remember, first term is given by A, common difference is given by D. In that case, nth term is always given by A plus n minus 1 D. Do you remember that result? Along with this, something really important, if nth term is given by A plus n minus 1D, we do know something really relevant to is by, I'll come back to this question, but before I solve this question, I wanted to discuss something really important. Sum of n terms of an AP. So sum of n terms of an AP is given by n by 2, 2a plus n minus 1 into d. Or if 2a can be splitted as 2a can be splitted as a plus a, then it is a plus a n minus 1 into d. So why are you doing this? Because a plus n minus 1 into d is your nth term. Let's say nth term is the last term. So if this here, a plus n minus 1d is denoted by last term L, I could write it as n by 2 a plus L. This is something very beautiful, highlighted or noticed by Ramanujam as well. He said that if there is an arithmetic progression, a sequence, which is in AP, then sum of first term, although not Ramanujam only, way before Ramanujam also, this was simply predicted. But the students must have been like Ramanujam only. Hello everyone. So A plus L, first term plus last term, divided by 2, multiplied with number of observations, will always give you sum of n terms of an AP. Did you get that? Now I'll come back to this question. Pay attention. It is again a very beautiful question. How do you solve this? Number of numbers lying between 100 and 500 that they are divisible by 7 but not 21 would be how many? Okay, that's a good question. How do we solve this? By the time I'm solving it, I'll be really happy if some of you could participate in this poll and tell me the correct answer. Sir, we are looking for the numbers which are divisible by 7. But those numbers should not be divisible by 21. Okay, so I think I'll be seeing two sequences. One sequence, the number which are divisible by 7, technically multiples of 7. Another sequence which is going to be a multiple of 21. How? Multiples of 7, which means what? 7, 14 and so on. But I am looking for the numbers between 100 and 500. Okay, so if I look at 100, 100 when divided by 7 gives you what? I hope you can do it mentally as well. 7 into 1, that is 7. Remainder is 3, 30. 7 into 5 is 35. 7 into 4 is 28. So remainder is 2. So I think 5 more I need to make it divisible by 7, which means 105 will be the first number which will be divisible. And after 105 plus 7 plus 7 plus 7 plus 7, so on until 500. But 500 I think is not divisible by 7. Let me check it. When I divide 500 by 7, what do I get? Pay attention everyone. 500 when divided by 7 gives you 7 into 7, 49. Remainder is 1. 7 into 1, that's clearly 3. So remainder is 3, which means if I come 3 units back, which means 497, that will be the last term which will be divisible by 7. So these are all those terms. Getting it everyone? Now, let's say this is a plus d and so on. So these are n terms. Now, how many terms are they? If I were to calculate it, I'll say these all are multiples of 7. They all are multiples of 7. Let me write it as 7k. So 7k means multiples of 7. How many are they? Can we calculate it? Yes. How? Let's talk about that. Sir, if this is the last term, 497, then it will be equal to first term plus n minus 1 into d. What is d? 7. Yes or no? So 497 minus 105. 497 minus 105 divided by 7 plus 1 will be the value of n. Yes or no? If I rearrange it like this. Everybody getting this? Now let's quickly do it so that we can get the final answer. Pay attention everyone. 497 minus 105 is how much? 2. 9, 3, yes or no? Divided by 7 plus 1 will be the value of n. So this, if I divide it by 7, 7 into 5 is 35. So this is 35. The remainder is 4. Then this is 6. So 56 plus 1, that is 57. What does this 57 imply? 57 would mean here that between 100 and 500, the numbers which are divisible by 7 are 57. My answer could have been 57, but unfortunately, there will be some numbers between 100 and 500 which will be divisible by 21. Those numbers I'm supposed to exclude. So let's count the numbers which are divisible by 21. Okay. So when I try and divide 100 by 21, what do I get? I think 20 into 5. 20 into 5 is 100. 21 into 5 is 105. So first such number which is divisible by 21 would be 105. I repeat, now I'm looking for the multiples of 21. So I'm writing that as 21m. And so on. So 105 plus 105 plus 21 plus 21 plus 21, so on. An AP will get formed. So what will be the last term? Okay, let's try and crack the last term. So I'm having 500 and I'm trying to divide it by 21. Let's see whether it is divisible by 21 or not. Of course, it will not be. But if I try and do so, 21 into 21 or 21 into 2 is 42. So this is 42. That leaves you with what? 8. Yes or no? So that leaves you with 80. Everybody got that? I hope no confusion. 42, that means 8, and this 0 gives you 80. 21 into 4 is 84. So 21 into 3 would have been what? 63. Correct me if I'm wrong. So this is your 63. Yes or no? So it leaves you with the remainder 17. Yes or no? It leaves you with the remainder 17, and this 23 is going to tell you everything. You don't really have to explicitly calculate the number of terms. But in the board examinations, you'll have to do it like this only, the way we are doing it. So the last term is going to be 105 plus 21 plus 21 plus 21 and so on until 500 is not divisible. 500 minus 17 will be divisible. So what is 500 minus 17? Pay attention everyone. 500 minus 10 is 490. 490 minus 7 is 483. So the last term which will be divisible here by 21 will be 483. Did you all get this? Although that quotient 23 we got would have given you the idea, but still if you are confused, I'll help you out with the simplest approach here. Pay attention everyone. If I want to calculate the number of terms here which are divisible by 21, lying between 100 and 500 is going to be calculated with this. Nth term 483 is equal to A, which is 105, plus n minus 1. Let's say here n minus 1 into D. Common difference is 21. Getting it everyone? With this will be 483 minus 105 divided by 21 is equal to n minus 1. So if I add 1 to it, it will give me the number of terms between 100 and 500 which are divisible by 21. Yes or no, participants? With this, if I simplify this, 83 minus 5, that I think is 78. 78 minus 100 is 378. Correct me if I'm wrong. So this is 378 divided by 21 plus 1 will be the value of n. So if I do it further, what do I get? Pay attention everyone. 21. 37 is not divisible. So 21 into 1 is 21. 37 minus 21. So we are doing this 37 minus 21. Pay attention everyone. It is 16. Correct me if I'm wrong. It is 16. So that gives you 168. And 168 needs to be divided by 21. I think it should be what? 8? Yes. 60? Yes, it should be 8. So that gives you 18. And 18 plus 1 gives you 19. So there you get n as 19. So there are 19 numbers which are divisible by 21. So 57 numbers which are divisible by 7, but 19 numbers are there which are divisible by 21. I needed the numbers which are divisible by 7 but not divisible by 21. So these are those common numbers which are divisible by 7 and 21 both. So I got to exclude these numbers. Getting my point everyone? Because any number which is divisible by 21 will be divisible by 7 as well. So these 19 numbers are those numbers which are divisible by 21 as well as 7. So Out of these 57, these 19 are to be excluded, and that will be my answer. 57 minus 20 would have been 37, but it should be 38 because it is 19. So that 38 will be the answer, option C. How many of you got it right? I'm sure some of you must have done it by themselves without using any AI or something like that. Shall I move ahead from here? Now, this is something which we have already discussed. Let us talk about a GP now. GP is also something very interesting. Let's say there are terms. Let's say there are terms like 1 into 2, 2, 2 into 2, 4, 4 into 2, 8, 8 into 2, 16. So previously, the difference was constant. This time, the ratio is constant, which means 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2. So this time, there is common ratio. So it means if there is common ratio, we call it geometric progression. Did you all understand this? Yes or no? I hope I'm not teaching way too fast. You're able to comprehend and understand all what is being said. Yes or no? So in AP, nth term is given by a plus n minus 1 into d. In GP, nth term is given by a r raised to the power n minus 1. What is a? A is always your first term. A is always your first term. R is your common ratio and n is nth term. Everybody got this? Everybody understood this? Now there is something really interesting and important which you should pay attention to is this part. Here. Let's say there is a GP like 3, 3 into 2, 6, 6 into 2, 12, 12 into 2, 24, into 2, 48, and so on. And there are 10 terms. There are 10 terms. And if I want to calculate the sum of these 10 terms, so if I want to calculate the sum of 10 terms of this GP, I can use either this or this. Both are same formula. You have just taken negative common from the numerator and denominator. The formula says A times whole of r to the power n minus 1 upon r minus 1, which means A is your first term, which is 3, times R. R is your common ratio, which is 2, to the power n. N means number of terms, which luckily in this case is 10, minus 1. A r to the power n minus 1 divided by r minus 1. What is r? R is 2. So this is 2 minus 1. So 2 minus 1 is 1. So your answer will be 3 times 2 to the power 10 minus 1. 2 to the power 10 is 1024. 1024 minus 1 is 1023. So this is 3 into 1023, which you all can easily evaluate, will be 3069. I hope I'm correct. So that's your final answer. So if you are supposed to add these terms, 10 terms, you really don't have to do it manually. With this formula, you can do it within seconds. Is it understood by everyone? Shall I move ahead from here, all the participants? Comfortable with whatever I've done? Now, there is something really beautiful which is said to be an infinite GP. What happens with infinite GP is, let's say if the common ratio is between minus 1 and 1. For a GP, if the common ratio is between minus 1 and 1. For example, let's take the common ratio as 1 by 2. So let's say the first term is 2. 2 into 1 by 2 is 1. 1 into 1 by 2 is 1 by 2. 1 by 2 into 1 by 2 is 1 by 4. 1 by 4 into 1 by 2 is 1 by 8. And so on until infinity. So if you locate these numbers, they are decreasing and they are getting very small, very small, very small. So they are getting very small and approaching close to 0. All these infinite numbers can be added mathematically. Can you believe that? Infinite terms can be added. Yes. And this summation of this infinite GP is given by A upon 1 minus R, where A is again your first term, R is the common ratio, which means here the sum of this infinite GP will be given by A, which is 2 upon 1 minus R. Common ratio is 1 by 2. 1 minus 1 by 2 is 1 by 2. 2 by 1 by 2 is 4. So that's your answer, which means all these infinite terms when added give you the answer as 4. Can you believe this? Yes. Can we try and solve this question here? Let's try and do it. Again, it's a MCQ. Let's see how many of you are getting it right. So let's conduct a poll and let's see whether you're able to do it or not. Shall we? Pay attention, everyone. How are we going to go ahead with this? Sum of n terms of this series. Okay, sum of n terms. Let's try and do that. 1 by 2. Let me just rewrite this question. 1 by 2 is 1 by 2. 3 by 4 can I write as 1 minus 1 by 4. 7 by 8 can I write as 1 minus 1 by 8. 15 by 16 can I write as 1 minus 1 by 16, and so on. I hope no confusion so far. Even if you are confused, 1 by 2 can I write as 1 minus 1 by 2? Sir, why have you done this? Why have you done this? Okay, pay attention. 1 by 2 I have written as 1 minus 1 by 2. 3 by 4 I have written as 1 minus 1 by 4. 7 by 8 I have written as 1 minus 1 by 8. 15 by 16 I have written as 1 minus 1 by 16 and so on until nth term. Although this is a special sequence which has different methods to be solved with the IIT-JEE approach, which I'm not discussing here. I'm trying to stick myself to the board approach here. So how do we solve this question in the board examination? Let's talk about that. So 1 plus 1 plus 1 plus 1 plus 1 n times. So if I'm adding 1 n times, it will be n. 1 added 3 times is 3. 1 added 10 times is 10. So 1 if added n times, it will be plus n. Did you all get this? With this, if I take this negative sign common, I'm left with 1 by 2 plus 1 by 4 plus 1 by 8 and so on until the nth term. Until the nth term. Everybody getting this? Yes or no? So here, this n remains n, but sum of a GP. I hope you remember we have just discussed a formula. Sum of n terms of a GP. Sum of n terms of a GP is given by A, r to the power n minus 1 upon r minus 1, or A, 1 minus r to the power n upon 1 minus r. If you take negative sign common from the numerator and denominator, it will become that formula which I have just verbally spoken. Now with this, what is A? If I write A, so this 1 by 2 here is your A. What is common ratio? I hope you are noticing common ratio is also luckily 1 by 2. What is n? Number of terms, which is n. Yes or no? Everybody getting that? So it will be given by A, which is 1 by 2 times 1 minus r to the power n. What is r? 1 by 2 to the power n divided by 1 minus r, which is 1 minus r. Did you all get this, or shall I repeat it? A, 1 minus r to the power n upon 1 minus r. I hope it is not confusing at all. Yes or no? Everybody, tell me. I hope so far there is no confusion on whatever is done. Everybody with me? Now with this, if I just simplify this, I probably will get the final answer. Yes or no? Everyone, tell me. So how do we solve this particular part? Pay attention everyone. If I solve this, I am left with n minus. I hope you're understanding 1 minus 1 by 2 is 1 by 2. And that 1 by 2 and this 1 by 2 are cancelled. So what am I now left with? Minus of minus, which is minus. Sorry, minus of plus is minus. Minus of minus is plus. So this is 1 by 2 to the power n. I think this must match with some of the options. It is n minus 1 plus 2 to the power minus n. And that clearly matches with option C. And I'm sure most of you must have marked option C. Yes or no? All the participants. I hope everybody is getting it. Now there comes some more important formulae. What are those important formulae? Let us talk about that as well. Everybody there watching, listening and understanding. Let's say someday if I ask you sum of first 10 natural numbers, so you don't have to do this 1 plus 2 plus 3 until 10. You can do it with the simple formula 10 into 11 by 2. Did you get it? Sum of first n natural numbers is given by n plus 1 by 2. Simple. If I ask you 1 square plus 2 square plus 3 square plus 4 square and 10 square, again you don't have to do it. There was a student of mine, she actually used to calculate it like this. Even though I gave her this formula, she was busy doing this 1 plus 4 plus 9 plus and so on. And I was very surprised by her methods. I hope you're realizing you don't have to do it if you're a student of mathematics. Yes? So with this, what you do is 1 square plus 2 square plus 3 square plus 4 square until 10 square will be given by 10 into 11 into 21 by 6. Did you understand whatever I've just said? All I'm saying is 1 square plus 2 square until n square, if it is needed to be done, it is given by n plus 1, 2n plus 1 divided by 6. Will you all remember that? Yes or no? Similarly, if I ask you 1 cube plus 2 cube plus 3 cube until n cube, it is nothing but square of sum of first and natural numbers. Did you understand it? I repeat. Let's say I ask you 1 cube plus 2 cube plus 3 cube until 10 cube. So your answer will be square of 10 into 11 by 2. That's it. I hope you are understanding that we'll be using these formulae in our journey. Now, Some basics from Trigo students find to be difficult. So let's talk about those basics as well. What are those basics? Let's have a crystal clear idea about them. I hope no confusion regarding one right angle, 90-degree. But if I ask you degrees into radians, I hope you remember 180 degree is pi radian. Radian as a unit is denoted by C, or even if nothing is written over there, this is also treated as radian. So pi is an irrational number. Its approximate value is 3.14. But in terms of radian, if it is converted into degrees, it is 180 degree. I hope I need not tell you, if I ask you 90 degree, will you not hesitate in saying pi by 2 radian? If I ask you 1 degree, I hope you're understanding 180 degrees pi radian. So 1 degree will be pi by 180 radian. Yes or no? Did you get it? So I hope with that, let's say if I ask you 30 degree, what will be your response? You will say 30 into 1 degree. But 1 degree is pi by 180. So in terms of radian, it will be 30 into pi by 180 radian. I hope it is understandable. 30 by 180 is clearly 6. So I mean 1 by 6. So 30 degree will be pi by 6. Everybody getting that? I hope so far there is no confusion. Let's say if I ask you 180 degree, you say pi. If I ask you 90 degree, you say half of it, which means what? Pi by 2. If I ask you 45 degree, you will say half of it, which means pi by 2 divided by 2, pi by 4. 30 degree was pi by 6. And if I ask you 60 degree, it will be pi by 3. These are the basic angles into radians, which I'm sure most of you must already be aware of. 3 most crucial identities which you all have been studying till 10th standard probably. Sin square theta plus cos square theta is always 1. I need not tell you that. 1 plus tan square theta is sec square theta. You already know that. And 1 plus cot square theta is cosec square theta. And its other variants, its other versions also, I'm sure you all are aware of. I hope I need not explain that. But something really interesting, if I were to ask you, I hope this is what you must have studied in probably 11th standard, but if you have forgotten it, this is the time that you revise it. Angles, I hope you understand. If I begin with this, this is your 0 degree or 0 radian. This is 90 degree or pi by 2. This is 180 degree or pi. This is 270 degree or 3 pi by 2. This is, if I'm rotating it anti-clockwise, so 90 degree, 90 degree, 90 degree, 90 degree is getting added. So 270 plus 90 is 360 degree, which is written as 2 pi. Again, if I keep adding pi by 2 like this, it will keep rotating in anti-clockwise direction like this. Now, what happens next is, remember this, that when you draw the graphs of sine, cos, tan, cosec, sec, cos, you will see between 0 to 90, they all are positive. Their outputs, their values, their range is positive. Between 90 to 180, only sine and cosec are positive. Between 180 to 270, it's only tan and cot, they are positive. And between 270 to 360, that means 3 pi by 2 to 2 pi, it's only cos and sec are positive. Sir, what is the meaning of this? Let's say someday I ask you to convert few things. Which few things? Let's talk about that. Let's say I ask you cos 2 pi. Cos, let's say instead of 2 pi, let's say 3 pi by 2 minus theta. So first of all, pay attention everyone. If here you see an odd multiple of pi by 2, then cos ratio gets converted into sine. Cos ratio gets converted into sine and sine ratio gets converted into cos. But 3 pi by 2, I think 3 pi by 2 is here. And if you're subtracting, you're pushing it in the third quadrant. In the third quadrant, tan and cot are positive, which means cos will be negative. So it will be minus sine theta. Did you all get it? I'll repeat it. Have patience. Let's say if I ask you tan 2 pi minus theta. So I repeat, if it was an odd multiple of pi by 2, then the ratios are changed. Sine into cos, cos into sine, tan into cot, cot into tan, sec into cosec, cosec into sec. But if it is a multiple of pi, the ratios don't change. So 2 pi, multiple of pi. So ratio will remain same, which means it will be tan theta. But what about its sign, positive or negative? 2 pi minus theta. This is 2 pi. Minus theta will push you in the fourth quadrant. In the fourth quadrant, cos and sec are positive. In the fourth quadrant, cos and sec are positive, which means 10 will be negative. Shall I come up with few more conclusions? Quickly give me a thumbs up. Are you comfortably getting it? Let's say if I ask you sine pi by 2 plus theta. Now, the moment you see pi by 2, so odd multiples of pi by 2 change the ratio, which means if it was sine, it will be cos. It will be cos. Now, pi by 2 plus theta. This is pi by 2 plus theta will push you in the second quadrant, yes or no? And in the second quadrant, sine as a ratio is positive. So if sine as a ratio is positive, it will be plus cos theta. Are you comfortable? I hope everybody got a decent idea how to deal with different angles and how to figure out these values. Everyone comfortably got this? Now, if I talk about few really crucial and important identities which you must have been using in your 11th standard journey is this. I hope nobody thinks like this, that if you are given sine 30 degree plus 60 degree, I hope nobody does it like this, sine 30 plus sine 60. This is not a product or this is not a bracket where you are multiplying sine with 30 and 60. No, it's not. It is the sine ratio of a particular angle. So if it is sine 30 plus 60, although it is sine 90, which you already know, but you can use sine A plus B as well, which means if sine A plus B is what you're supposed to figure out, it will be sine A cos B plus cos of sine B. I'm sure most of you are aware of it. If I ask you cos A plus B, it is cos A cos B minus sine A sine B. If I ask you tan A plus B, it is tan A plus tan B upon 1 minus tan A tan B. If you divide this by this, you get this. Similarly, sine A minus B will be sine A cos B minus cos A sine B. Cos A minus will be cos A cos B plus sine A sine B, these two ones. And similarly, tan A minus B will be tan A minus tan B upon 1 plus tan A tan B. Everybody got this? I hope these few you will remember. These are some standard graphs which you got to remember. Sir, why? Because they'll help you a lot in solving a lot of questions. How? Let's talk about that. First of all, if I ask you, where do you see sin x to be 0? Sir, at 0, pi, 2 pi, 3 pi, 4 pi, sin x is 0. When do you see cos x to be 0? Sir, at pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, cos x is 0. When do you see sin x to be 1? Sir, sin x is 1 at pi by 2, then 5 pi by 2, and so on. When do you see sin x to be minus 1? Sir, at 3 pi by 2, 7 pi by 2, and so on. When do you see cos x to be 1? Sir, cos x is 1 at pi by 2, then 5 pi by 2, and so on. Oh, I'm really sorry. Cos x is 1. Cos x, I'm saying. Cos x is 1 at 0, then 2 pi, then 4 pi. Cos x is minus 1 at minus pi, 3 pi, 5 pi, and so on. So if you remember these graphs, these generalizations will be really simple and you'll be able to deal with these questions very easily. Now, let's talk about one more result, the graph of 10x. The graph of 10x goes like this. Let's say between minus pi by 2 to pi by 2, if I try and draw it, it is strictly increasing function like this. Between minus pi by 2 to pi by 2, I'm saying. And it goes from minus infinity to plus infinity like this. And this is a periodic function, so it keeps on getting repeated like this. This is how you plot the graph of 10x. Shall I move ahead from here? Now, we are gradually moving from trigo to coordinate geometry. Shall we? What is coordinate in this case? First of all, if there is a point x1, y1, x2, y2, distance between this point P and Q is given by, I hope you know that, distance between this point P and Q is given by under root over x2 minus x1 whole square plus y2 minus y1 whole square. Everybody knows that. Everyone comfortably getting it? Yes or no? With this, few more general results, you know that if I talk about few things in general, what are things in general? Let's say this is y-axis and x-axis, and this is a point, this is another point. This is a point 2, 3, and this is a point 5, 3. So I hope you're realizing this is how these points are placed. So the distance between them, you may notice that, sir, it is parallel to the x-axis. If it is parallel to the x-axis, you can simply take the difference of 5 and 2, which is 3, and that's the distance. I'm getting it, everyone? So these kind of stuff, that kind of stuff is written over there. I hope you got it. No confusion with this. Section formula is really important. It is something really important and crucial. How do we use it? Let's say there is a point x1 comma y1, there is a point x2 comma y2, and there is a point in between this line segment joining AB, which is given by px comma y. And I know distance AP is to distance PB is m1 is to m2. So always remember, you can always find out the coordinates of P by using a simple formula. m1 times x2 plus m2 times x1 upon m1 plus m2. That will be the x coordinate. Similarly, m1 times y2 plus m2 times y1 upon m1 plus m2 will be the y coordinate of this point P. Are you all getting it? Are you all understanding this? I hope it is comfortable, convenient, and clearly understandable. Yes or no, everyone? With this, section formula is what we'll be discussing now. Sir, what is the section formula here? In terms of external division. Sir, what was that? It was internal division previously. It is external. External division means this is the line segment which is created by joining AB. And there is an external point P, which is either on the right hand side of B or on the left hand side of A. In this case, let's say right hand side of B. So, if I find this distance AP, which I find to be M1, and then BP, which I find to be M2, which means this whole distance AP upon BP, this ratio if I find will be M1 is to M2. Now, if it is an external division, in that case also you can find out this x comma y. How? Pay attention everyone. Pay attention everyone. I'll just write it for the simplicity here. What is M1? This whole distance here is M1. And this distance over here is M2. Right? First of all, did you all understand this? Now, how do we use section formula for external division? Pay attention everyone. x1 into m2 minus external division. That's why minus x2 into m1 divided by m2 minus m1 will be the coordinates of x. If you take negative sign common from the numerator and denominator, it will become what I have just said. So this formula written over here and what I have just said is same. And y1 into m2 minus y2 into m1 divided by m2 minus m1 will be the y coordinate of P. Did you all understand the external division formula or section formula here? Yes or no? Sir, what if the point P over here is the midpoint of AB? What happens in that case? I think ratio becomes 1:1. M1 and M2 become 1. Internal division. So I hope you're understanding. Midpoint is given by x1 plus x2 by 2, comma y1 plus y2 by 2. Something really simple, basic, easy, understandable, and you must have remembered it. These are some points, additional points I'm keeping in the PDF, which is there, kept for your revision. So when you do the revision of this from this PDF, you can study it by yourself. I hope you know that you can avail this PDF by downloading it. How can we have it, sir? You can have it by following our WhatsApp channel. Sir, how can we follow your WhatsApp channel? The link is given in the description. Now, getting back to the discussion. Let's say there is a triangle given by x1 comma y1, x2 comma y2 and x3 comma y3. These are the three vertices of that triangle. And we are supposed to figure out the area of this triangle. Now, no matter what kind of triangle it is, equilateral, isosceles, scalene, right angle, whatever kind of triangle it is, we can figure out its area using coordinate. How? There is the determinant formula which says half mod of determinant of x1 y1 1, x2 y2 1, x3 y3 1. Sir, but we don't know how to solve this determinant. I accept it. In 11th, you haven't studied it, but in 12th, we'll be studying it. How to expand a 3x3 determinant. So when you enroll for the PARISHRAM batch, which is there for class 12th English medium students, we'll be talking about that. Don't worry about that. From here, if I go ahead, I think this is what you already know. I need not explain that. Now, straight line when we talk about straight line, let's say there is a straight line. So if it is given by 3x plus 2y minus 2 is equal to 0. So a linear equation in two variables x and y represents a straight line. Simple, decent, straightforward. And if I ask you a few more things related to it, let's say there is this y-axis, this is your x-axis, and that's your straight line. That's your straight line. Let's say this line is given by y is equals to mx plus c, a linear equation in two variables. Then this straight line makes an angle theta with the positive side of x-axis in anti-clockwise direction. Then if I take its tan ratio, it will be called the slope of the line. I hope you know that. And this c here is the intercept made by this line. So I hope slope and intercept you already know. Yes or no? Yes or no? Yes or no, everyone? Now, let's say, sir, if we don't want to use that, can we have some other method? Yes. Let's say this straight line contains 2 points. One of the points is 2, 4. Other point is, let's say, -1, 3. I'm just randomly drawing them. And let's say I want you to help me in writing its slope. So slope of a straight line is always given by y2 minus y1, which is 4 minus 3, upon x2 minus x1, which is 2 minus minus 1, which is clearly 1 by 3. I hope you got it. Everyone comfortably? Yes or no, all the participants. With this, there is one more interesting thing. Let's say there is a straight line, 2x plus 3y minus 6 is equal to 0. Right? And this line is intersecting x-axis and y-axis at 2 points. What are those points? So if I want to find the y coordinate if I want to find the points where it is intersecting y-axis, so the point where this line intersects the y-axis will have x coordinate 0. So if I put x as 0, 3y is equals to 6. So y will be 6 by 3. That's 2. So point where this line will intersect the y-axis will be 0, 2. Not just that, let's say I want to know where does this line intersect the x-axis. So if it is intersecting x-axis, their y coordinate will be 0. So this 3y will be 0. So 2x is equal to 6. That means 6 by 2. That means 6 by 2. That is 3. So this line will intersect x-axis at 3, 0, y-axis at 0, 2. Everybody understood that? I hope it is clearly digested by everyone. Now let's talk about factorial notation. What is factorial notation? Pay attention, everyone. It is again a really simple idea. Product of first n natural numbers is given by n factorial. Let's say if I'm doing 3 into 2 into 1, that's 3 factorial. If I'm doing 5 into 4 into 3 into 2 into 1, that's product of first 5 natural numbers. It is given by 5 factorial. And so on. Getting it, everyone? Yes or no? Yes or no? So I think that is all about factorial. You already know it. Regarding factorial, if I move ahead, let's talk about binomial. Now, binomial expansion is something really simple and decent. If I wish to write x plus y to the power n, I think we already have this formula. I hope you know how do we write x plus y square. I hope you know how do we write x plus y cube, and so on. If I look for the generalized result, Pascal gave that generalization and Newton came up with the formula for binomial theorem, and that final formula was this. If it is confusing for you, let me write it in its simplified format, which you must have studied in 11th. Let's say I'm given x plus y to the power 7. Then what does it say? It says you write 7c0 first. This x you raised to the power 7, y you raised to the power 0, plus. Now you write 7c1, x from 7 it becomes 6, y from 0 it becomes 1. Next term will be 7c2, x to the power 6 minus 1, 5, and 1 plus 1, 2, and so on, and so on, and so on. And ultimately, you write the last term 7c7, x to the power 0, y to the power 7, and that's it. Your job is done. So that's how you write the binomial expansion. Getting it, everyone? Yes or no? This will be using sometimes in class 12th. If I ask you the r plus 1th term in x plus y to the power n, if I ask you the r plus 1th term, it is given by NCR x to the power n minus r, y to the power r. Let's say, for example, if I ask you x plus y to the power 15, and if I'm asking you to write the 13th term, So T13 is T12 plus 1. So it will be given by x plus y to the power 15 I'm asking, right? X plus y to the power 15. I'm asking you the 13th term. So there, if I wish to write the 13th term, how will I do it? Pay attention, everyone. NCR. What is N? N is 15 here. So 15CR. R is not 13. R is 12. So 15C12. X to the power N minus R. So x to the power 15 minus 12, that's 3. Y to the power R, what is R? That is 12, and that's your 13th term. Everybody understood that? Did you all get a crystal clear clarity on binomial expansion of positive integral? Similarly, if instead of x plus y, it is 1 plus x to the power n, you, I hope, are comfortable now in expanding it. Now, arithmetic mean and regarding, I think, statistics, I'll be skipping that discussion right now in this session. Statistics will do someday specifically as a single entity that you need not worry about, that you need not bother about. So I think I am done with this session. I'm absolutely clearly done with this session. This session was majorly intended or to be kept for basic simple idea, where I wanted that if you are moving from class 11th to class 12th, which you have already moved, then in class 12th mathematics, in class 12th maths, you use a lot of basics from class 11th. You use a lot of learnings from class 11th, which means learnings like logarithm, learnings like sequence and series, learnings like trigo, learnings like complex numbers, learnings like theory of equations like quadratic equations, and a lot more. So if you are entering into class 12th, we want you to enter into class 12th comfortably. We want you to enjoy class 12th with utmost sincerity and dedication. Well, that happens when you don't have any confusion, when you don't have any doubts. So doubts you won't face when your foundation is clear, when your 11th is clear. But most of you come up with this excuse, not an excuse technically, but this idea that, sir, we have wasted our class 11th. We have not studied it properly. We were very casual. We were not very much focused. In that case, I'll say you still have this opportunity that through this session, we have tried covering those important basics of class 11th mathematics, which will be really useful in class 12th through this video. So if you watch it properly, you will get some insights, decent insights, which will definitely help you in making your journey of class 12 mathematics easy. So if you want it, PARISHRAM batch is there for you all in English medium only, where we'll be teaching you in pure English. So PARISHRAM for class 12th, mathematics class will be taken by me. We are there to assist you. The batch is already started. The link is given in the description. And I'm sure you must be willing to join if you are willing to prepare in English. So with that, let's call it a day. We'll meet someday with some other discussion in some other class. Thank you so much. You have been a great audience. I am sure I must have helped you in some possible way. Thank you so much, everyone. Have a good day. Good night.